In the marina, you hear this all the time. A motor yacht burns fuel like a hell. The only problem with this myth is that people often look at the wrong metric. And the second thing, and this is the paradox that blows your mind, sometimes by going slower, you can burn more over a distance. Today I will break this down technically, where the concept of liters per hour came from and why it is misleading from a marketing perspective, what the financial death valley is in terms of burn rate, and how much fuel really costs for a week of charter, for example, in Croatia. In the segment of motor yachts, there is a deeply rooted cognitive bias. Most people think in terms of fuel consumption in liters per hour. This is a metric important for engineers and service, but fundamentally inadequate for planning a voyage and costs. The aim of this episode is to switch to the only reliable unit of transport, liters per nautical mile. Why does the industry stubbornly provide liters per hour? Because it makes sense in the laboratory. Marine engines are tested on dynamometers under stationary conditions, and their efficiency is described by the BSFC parameter, which stands for brake-specific fuel consumption. What does it mean exactly? It is information on how much fuel the engine consumes to produce 1 kilowatt of useful power at the shaft, i.e., brake power, at a given operating point. For a mechanic, the hour of work is the only constant, but water is a dynamic environment. Current, wind, and waves make the nautical mile not energetically constant. Manufacturers like liters per hour because it provides a nice picture. The number increases quite linearly with the revolutions. Meanwhile, hydrodynamic resistance, and thus real consumption per mile, increases non-linearly and can even grow exponentially. Example, only 50 liters per hour. Sounds great, but at 7 knots, that's over 7 liters per nautical mile, and suddenly the terrible 150 liters per hour at 30 knots can yield around 5 liters per nautical mile. The paradox, a more expensive hour can be cheaper for the wallet. Now the math that ends the discussion. Transport efficiency is liters per mile equals liters per hour divided by speed. And this is where the classic trap arises. Let's consider an example that often confuses beginners. We have a yacht sailing at 10 knots that consumes 80 liters per hour. And we have the same yacht sailing at 20 knots but consuming as much as 160 liters per hour. Intuition suggests, wow, at 20 knots I'm burning twice as much. That's a mistake. Let's calculate it. In the first case, 80 liters divided by 10 knots gives us 8 liters per nautical mile. In the second case, 160 liters divided by 20 knots. It's still 8 liters per nautical mile. The transport efficiency is identical. The fuel cost to reach the destination is the same. The only difference? In the second case, you arrive at your destination twice as fast. Using the parameter per hour suggests savings where there are none. Why is faster sometimes cheaper? Water resistance is non-linear. The yacht moves in 3 modes: displacement, hump speed, and planing. But that's not all. Often going faster is actually cheaper. To understand this, we need to discuss 3 modes of sailing. The first is displacement sailing, about 6 to 7 knots. The yacht cuts through the water, fuel consumption is minimal, around 1 to 2 liters per mile. Then we enter the so-called planning speed or hump speed. This is usually a range of 10-15 knots for a 40-foot yacht. The yacht tries to climb onto its own bow wave. The bow rises, the stern sinks into the water. The engines roar, the load is at maximum, and we churn the water, creating a gigantic wake. This is the financial death valley. Fuel consumption per mile is highest here. Only when you add throttle and enter full planing, say 25 knots, does water resistance drop sharply. The yacht lifts out of the water, and here the magic happens. Fuel consumption per mile decreases. The optimum depends on the design. Displacement hulls like trawlers, it's best not to exceed the hull speed. At 6 knots, they consume symbolically, but above that, the consumption rises sharply. For planing hulls like most yachts you know, such as Azimuth or Sunseeker, the golden rule is either very slow at 6 to 7 knots or fast at 22 to 25 knots. Avoid the zone in between because that's where economic disaster lies. See data for Regal, 42 fly. At 10 knots, you consume over 6 liters per mile. At nearly 28 knots, just under 4 liters. When cruising slowly in a swell, you lose 70% more money. Let's now move on to economics. There is a myth that a motor yacht means burning thousands of euros a day. Let's check this with the example of a typical weekly charter in Croatia. The route split to Hvar, to Vis, to Korčula and back is about 175 nautical miles. During a week-long vacation, you don't sail non-stop. You sail an average of 2 to 3 hours a day, and the rest of the time you are at anchor. If you sail wisely, meaning mixing displacement mode with planing, the average consumption will be about 2.5 to 3 liters per mile. 175 miles times 3 liters is 525 liters of fuel. At a price of 1.50 euros per liter, that's a cost of about 780 euros for the whole yacht. Divide that by 8 crew members. That comes out to below 100 euros per person for a week of fuel. That's a fraction of the charter price. However, there is one catch that I must mention to maintain full professionalism. The yacht also burns fuel while stationary. The generator needed for air conditioning consumes between 3 to 4 liters per hour. If the crew requires air conditioning all night and during the day while at anchor, the generator can run for 16 hours a day. Over a week, it can burn more than 300 liters of fuel. This is a key takeaway. Often, the larger fuel bill is generated by thermal comfort at anchor rather than by sailing itself. Managing air conditioning, cooling the cabins in the evening rather than running non-stop, provides the greatest savings. In summary, first, ignore the liters per hour parameter in catalogs, ask about liters per mile. Second, faster often means cheaper. Avoid the hogging speed where the bow is raised and the stern is sinking. Third, motor yachting doesn't have to break the bank if you understand hull hydrodynamics. Remember, at sea, distance matters, not time. Sail wisely, calculate consumption per mile, and don't be fooled by marketing tricks. If you want a calculation for your yacht, write the model and route in the comments. I'll do it in the next episode. See you on the water.